Alright guys, so for this video we're going to be going over vertical asymptotes. Before we even start approaching that, I want to talk about what we mentioned in the last video, which were holes. Remember, we were talking about this function 4 times x squared minus 4 divided by 2x plus 2. And we said that there was a hole at x equals minus 1. And if we were to plug in minus 1 into this function, we'd get 4 minus 4 divided by minus 2 plus 2. And what happened was we would get 0 divided by 0. So we can't really do anything when we have a 0 divided by 0. Things become undefined. So what we had to do was we had to simplify. And after we simplified this equation, things ended up canceling out, and we got to a much neater equation of 2x minus 2. And by canceling terms out, we were able to avoid this 0 over 0 situation, but we did create a hole in this line of 2x minus 2. Now, vertical asymptotes, similar things occur. See, for a vertical asymptote, we can identify if a vertical asymptote occurs if we still plug in an x value. If we were to still plug in the x value and a 0 occurred only in the denominator, okay? So how do we find if our function has a vertical asymptote? Well, we set the denominator equal to 0 and see if anything makes it 0. So example 1, here's our example, 2 divided by x minus 1. I want to know if this rational function has some sort of vertical asymptote, which is an invisible vertical line that our graph does not cross. So what I'm going to do is I'm going to set our denominator equal to 0. So that's what I did right here. X minus 1, our denominator, I set it equal to 0. Once I solve for x, I see that if I let x equal 1, I get 2 divided by 1 minus 1. A 0 occurs in my denominator right here. See? And we know that we cannot have zeros in the denominators. We can't have i's in this class. So what we have to do is we have to avoid choosing 1 as one of our x's. And that's where a vertical asymptote occurs. Now in the next video, I'm going to show you a picture of it, so it's going to make a little bit more sense. But right now in this video, I'm just showing you how to identify where the vertical asymptotes occur. So let's look at our next example. Here we have x squared minus 9 divided by x squared minus x minus 12. And remember, again, we're going to use the same rule. I would really put some time into remembering this guy because it pops up everywhere. Difference of squares formula, right? If I have two squares, right, here I have x squared minus 3 squared. 3 squared is just 9. I have the difference of two different squares. They can break up into x plus 3, x minus 3. And notice our denominator can also be factored into x plus 3, x minus 4. I look at this guy and I see that I have an x plus 3 in the numerator and denominator. So what I'm going to do, I'm just going to cancel out those two terms. Boom, they go away. And what am I left with? I'm just left with an x minus 3 in the numerator and an x minus 4 in the denominator. So I want to know if this guy has a vertical asymptote, this simplified version. So what do? Same process as before. I set the denominator equal to 0. I set the denominator equal to 0, and I solve for x. This says that if I let x be 4, my function will, in a sense, break. So if I let x equal 4 for this function right here, I get 4 minus 3, which is just 1, and 4 minus 4, which is 0. So again, I get this 0 in the denominator. So I want to avoid letting x equal 4 because things get a little crazy when I have 0 in the denominator. So this tells me that I have a vertical asymptote at x equaling 4. Okay, this is our conclusion. So we know for our graph of this rational function, we have a vertical asymptote at x equals 4, but also we canceled out these terms. Remember in the previous video we said that anytime we cancel out something from the numerator and denominator, what occurs? A hole. So we also have a hole wherever x plus 3 equals 0. And if you follow the work from the last section, we know how to identify the hole. Take out the canceled out term, set it equal to 0 to find the x-coordinate of the hole. Take this x-coordinate, plug it into our simplified equation, which here is x minus 3 divided by x minus 4, and I get, just follow the algebra here, I plug this number into this function, the simplified function, and I get minus 6 divided by minus 7, a negative divided by a negative, it's just a positive. So I'm left with positive 6 over 7. So that means not only do I have a vertical asymptote at x equals 4, but I also have a hole at minus 3 and 6 over 7. So here's where our hole is. So two things are occurring in this one rational function. All right, in the next video, I'm going to graph it for you guys. All right, see you there.